3 now, so I'm gonna get started. So this is what we're here for, MA123 final, first final of college. Excited?
Yeah.
Love the enthusiasm. So these topics right here are the ones that have been on in the past. This test is kind of like, the first test was like test of convergence, Taylor series. There's like two big things, that was all you had to do. This one's like a kind of a lot of little things that they're all related a little bit, but also kind of different. So we'll do an example of each one, we'll touch upon each one, and then if you have any questions, I can answer those as well. Is there anything on here that you don't think is on the test, or not on here that is on the test? Cool.
Like, does radius and convergence mean like sine convergence and like
Yeah. Yeah,
Or like
interval of convergence.
Orthogonal vectors, is that like under?
Orthogonal vectors is under cross product.
Okay, cool.
Like collisions, intersections of like
oh, yeah.
two different things. Like,
I think that would be under
two particles
parametrized.
moving, whether or not they collide or their paths intersect.
That, so like I have an example on here, but last year they didn't have it on the test. So like I can do that one at the end, but that one's like extra section. Like I have on here like circular motion, arc length, rectilinear motion, all that stuff that
Oh, arc length is
arc length, yeah. Yeah.
You know if it's rare for them to put it on the test? Like, was it just last year? Or did you have-
Well, so I have a test on my computer, and then I have my test also. In my test, we just had find the distance traveled by the particle between the points.
Okay.
Like find velocity, acceleration, find the distance traveled. We didn't have anything with paths intersecting. Like I said, I have an example in the notes that I can do if you want that has to do with that kind of stuff that I got from the homework, but it hasn't been on the test, and they don't like to change up the test at all. If you guys saw from the midterm, was it not exactly what I told you it would be?
Yep.
Yeah.
So they, like through MA124, Diffie Q stays pretty much the same, but then like once you guys get to Multi, you'll actually have a different math test from the previous semesters. I'm sorry, but up until then, you're safe riding with past tests. Okay, so are there any other questions before I start with some rays of convergence? Sweet. So this topic probably should have been on the last test. It makes so much more sense to be on the last test because it fits with that material, but they just decided to throw it in here because, I don't know. So we got some rays of convergence. And this also deals with interval of convergence and everything with convergence. So basically the thing that you need to know, main formula is the limit as n goes to infinity of a sub n plus 1 divided by a sub n is less than 1. For these situations, whatever your a sub n plus 1, if this is true, then it converges. So it's going to make more sense when I get into an example.
It should be absolute value.
Yeah, it should be absolute value, but it doesn't really matter. I kind of drop it out a lot of the times. But yes, it should be absolute value. And the whole idea of this is if you take some term, a sub n, and you go to the next term in the sequence, the next term in the sequence should be smaller than the previous term, which the absolute value is less than 1. And if that's true, then it converges, and you find what interval it converges over. So, like I said, it's going to make more sense when we get into an example. So I'm going to start off with this first example right here, and then I'll go to the example that we had in our test. So this one's a little bit simpler. So we got the summation from n equals 0 to infinity of n factorial squared over 2n factorial x to the n. Okay. So we look at this and we apply it to that. So, and again, we should have these absolute values here. So what we do is we take this right here is our a sub n, because it's the term inside of my summation. So I'm going to take this, and everywhere that there's an n, I'm going to change it to an n plus 1. That's the first step. So inside here I have n plus 1 factorial squared. And again, anywhere you have an n, put the n plus 1 in parentheses, because that's going to take care of all of your order of operations, things that you need to consider. If wherever you have the n, plug in n plus 1 inside of parentheses. So now here we have 2, so it's going to be 2 times n plus 1 factorial x to the n plus 1. And I'm just going to put this in the numerator right here. So we have this a sub n plus 1. We're going to divide that by what we started with. So instead of dividing by what we started with, I'm just going to multiply by the reciprocal, because that's what math tells us to do. So I'm just going to rewrite this, but flip it. So we're going to have 2n factorial over n factorial squared x to the n. So it's just taking that, flipping it over. And now you get to simplify. So the first thing I'm looking at, we know that if we have something in the numerator, something in the denominator on either side, we can cancel it off. So I'm looking at this x to the n plus 1 power, and then divided by x to the n. So I know that this is really, so x to the n plus 1 is really x to the n times x to the 1. And if I have x to the n times x to the 1 over x to the n, I'm just left with x. So the first thing I'm going to rewrite on this side is just x. And I know those are gone. Next thing I'm looking at is I'm going to distribute this out. Yeah, I want to distribute it out. So we're going to have this term right here becomes 2n plus 2 factorial. So now this one's gone. I'm just going to rewrite 2n plus 2 factorial right there. So now I'm looking at this 2n factorial and 2n plus 2 factorial. So what factorial means is you take a number and you multiply it by everything smaller than itself. So if right here I have 2n plus 2, I'm going to be multiplying it by 2n plus 1, 2n, 2n minus 1, and so on forever. Well, I know that this 2n factorial means 2n times 2n minus 1 times 2n minus 2, and so on forever. So if I look at the terms in the numerator and I look at the terms in the denominator, well, 2n minus 2 is right there, minus 1, 2n. The only two terms I'm left with are these first two terms. So the 2n plus 2, 2n plus 1. So that's what I'm going to bring over to this right side, and since it's in the denominator, I'm going to leave it there. So we have 2n plus 2 times 2n plus 1. And then that's gone. And then the last thing that I'm left with is this n plus 1 factorial squared and n factorial squared. So for the same reason that we just had right here, the only thing that I'm going to be left with is an n plus 1 squared. N plus 1 squared. Okay, so now we did this step of finding a sub n plus 1 divided by a sub n. Now, we need to take the limit of this as n goes to infinity. So looking at this, we're going to take the limit as n goes to infinity. So this term right here is going to be, no, it's not. Oh, that's right. So now, bringing this term back out, I'm going to multiply it back out. So that way I can have a second power and a second power of n. Because I know when I'm taking limits with terms of infinity, the highest power in a given term is what drives it. So if I had an n cubed, that would drive this term, but the highest power that I have is an n squared. So I'm going to multiply these all out. So I'm going to take this becomes x times n squared plus 2n plus 1. And all I did was just double distribute, n plus 1 times n plus 1. And then here, I'm just distributing this out. So we're going to have 2n times 2n will give me 4n squared. That'll give me plus 2n plus 4n, so I have plus 7n, and plus 2. Now, since I'm taking the limit as n goes to infinity, only the highest power matters. So I can ignore the 1, I can ignore the 2n, I can ignore the 2, I can ignore the 7n. And all I'm left with is x n squared over 4n squared. So this is very unorganized, but I'm bringing it back over here. So we have x n squared over 4n squared. And the idea of this is we now have n squared. Those divide out. And all that we're left with is x over 4. If it's asking us to find the radius of convergence, we now do this last step, set it less than 1. And we can, and technically this is still the absolute value. And again, that's why I don't carry it through the problem because it would be too difficult to keep writing the absolute values. But I know once I get to this step, the absolute value of what I have here, less than 1. So since I have the absolute value, I go x over 4 is less than 1, and I have negative x over 4 is greater than, or no, x over 4 is greater than negative 1. Solve each one, you get x is less than 4, x is greater than negative 4. And at this point, it depends what the question's asking you. If it's asking you for the interval of convergence, you know that x has to be greater than negative 4, less than negative, or less than positive 4. So it would look like negative 4 to 4. Yes?
We don't have to test the endpoints.
Yeah, you should probably test the endpoints. It's not as important, but you should, yeah.
Our professor Ishikov said that basically that we're not going to worry about this endpoints.
I was just gonna say
Okay, so don't test endpoints. Cool. That's probably why I didn't have them in the notes. I just didn't remember why. Ignore endpoints. So we have negative 4 to 4. That would be our interval of convergence. I think that's what they ask for most of the time. If they were to ask for radius of convergence, all that means, radius is the distance from the center to the edge. So you find the center of this, which is simple to find, being 0, and the distance from the center to one edge is just 4. So the radius of convergence for this one would just be 4. And again, it depends what they're asking for in that specific question. Does that make sense? If so, I'll go on to the example that we had on our test.
I have a question.
Yes.
Since the radius of convergence is technically defined as 1 over that limit, when do you like actually do that with 1 divided by the limit?
The method that you showed us was a shortcut regression. You don't actually have to use it.
Are we good? Does that make sense? Okay.
What was that?
And like, if that didn't make sense, then when I do this next problem, it'll be clear.
Yeah, I don't like doing it though, it's just easier.
What's the difference in
What was the answer for
That
it?
instead of setting it less than 1, whatever the limit is
Well,
equal to.
again, it was if it asked for the interval of convergence, it would be
So like, we got that it was equal.
-4 to +4. If it asked for the radius of convergence, it would just be 4.
So when we equal the limit, it would be 1/4, 1 over like intervals 4, radius is 4. Does that make sense? So if you leave out the x term, it's gonna be 1 over whatever your limit equals. But if you keep in the x term, it's solve like this, then. I'm gonna write that down.
Oh, yeah.
Then it's like always conversion. Does like no conversion to that index. I'll literally give us one like that.
Can you text me that? Can you text me that?
Okay, so this was the first example that we had on our
But
test.
Sergey did it something.
It had this
It's
written.
confusing.
It says, find the radius of convergence of the power series, worth 8 points out of 50. So, first question here. So we look at this formula, start at the middle, work your way out. So we start at the middle. Let's find what a sub n plus 1 divided by a sub n is. So a sub n plus 1. We have -1 to the n plus 1. We have x minus 2 to the n plus 1. And we have n plus 1 cubed plus 2 times 3 to the n plus 1. That's just plugging in n plus 1 everywhere we had an n. And we're going to multiply this by the reciprocal of that same thing we have on top. So n cubed plus 2 times 3 to the n over -1 to the n, x minus 2 to the n. Now we have to simplify this. So I'm just going to start with my -1, -1, because anything that's just initially raised to n is going to simplify nice and easy like this, because all I'm going to be left with is a -1 on top. Because -1 to the n, -1 to the n will divide out. I'll just be left with -1 to the 1. So I have -1 left on top. Then, the same thing happens with my x minus 2's. Since I have this to the n plus 1 and that one just to the n, I'm just going to be left with an x minus 2 in the numerator. I look at my 3's, the same thing, except now I have an extra term in the denominator. So I'm going to have a 3 left in the denominator. So I've canceled that, I've gotten rid of that, and I've gotten rid of that. And now I see that I have an n cubed plus 2 and an n plus 1 cubed plus 2. And looking at this, I don't see an easy way to simplify it. Because I look at that and I say, okay, well there's no factorial, so I can't do the trick that I did in the last question where all of them but this term or these two terms cancel out. So I said, you know what? I don't think I can simplify it anymore right now. I'm just going to bring both of them over. So I'm going to bring over this n cubed plus 2. And I'm going to bring n plus 1 cubed plus 2. And I'm just going to leave it like that for now. So we're working our way inside out. Right now, I have a sub n plus 1 divided by a sub n. That's what that term is right there. Again, we have the absolute values. The next thing, working our way out, we take the limit as n goes to infinity. So I'm going to swing it over here. -1, x minus 2, n cubed plus 2. Over 3. And what I'm going to do for this one, just like I did in the last question, I'm going to expand it out. Because I know when I take n going to infinity, the only term that matters is the one that has the highest power. Because if I have 2n squared plus 3, this term is going to get big very, very quickly because it's an n squared and I'm going to infinity. The 3 is going to have a very little impact on the answer very quickly. So when I take the limit, that I can ignore. So I'm going to expand this out so that way I can only focus on one term and I can cancel off all the others. So n plus 1 cubed is going to be n cubed plus 3n plus 3n squared plus 1. And that's just doing n plus 1 times n plus 1 times n plus 1. So I'm going to bring that right here. We have n cubed plus 3n squared plus 3n plus 1. And now I'm taking the limit as n goes to infinity. All of the terms that aren't the largest, I can ignore. So in the denominator, I'm just left with 3n cubed. And this plus 2, again, can go away. So now I have a factor of n cubed and a factor of n cubed on the top and bottom. So now this n cubed divides out with that n cubed. Does that make sense? So what I'm left with, after I take the limit as n goes to infinity, is -1 times x minus 2 over 3. Sorry. Yeah.
Can you get rid of the -1 because it's an absolute value or not?
So we're going to.
Okay, just
But-
wasn't sure.
Yeah, so the one thing that, don't get rid of it yet, because it's going to impact it, and I'll show you. So, to make it a little easier, I'm gonna get rid of it, I'm gonna just make this a negative out in front, so it's not a -1. So we're just left with that right now. A negative x minus 2 over 3, and now we do the last step of setting this less than or equal or less than 1. Now, with an absolute value inequality, we have to break it up into 2. So, yeah, you could get rid of it in the first step, and you could divide it out, or not divide it out. You could get rid of it now. I didn't in my work, but you would get the same answer. You should get the same answer. So, when you're breaking up an inequality, an absolute value inequality, the first thing is you take it as it is. So you make one inequality that's negative x minus 2 over 3 is less than 1. So we just rewrite it without the absolute values. The other term, keep the left side the same. So we have negative x minus 2 over 3. Switch the direction of the sign. Is greater than, make it a -1. So now we're going to solve both of these, and that'll give us the 2 bounds for our interval. So over here, I'm going to multiply both sides by 3. So I can get rid of that denominator. Then I'm going to divide the -1. But when I divide by -1, what do you got to do? Switch it. So we have x minus 2 is greater than -3. I add 2 over. And I get x is greater than -1. Little piece of advice. It's very tricky for college level people. When you multiply this 3, you have a 1 over here. 1 times 3 is in fact 3. It is not 1. Because that's what I did. And I lost 2 points for it. Because 1 times 3, 1. I mean, that's what I thought. But yeah, so you end up getting that bound is -1. Do the same thing over here. So I have a negative on both sides. These are going to go away. Multiply by 3. 1 times 3 is?
One.
Well, because I'm dividing by, there's a negative on both sides. So I'm not, oh yeah, I do have to flip it. You're right. Because otherwise I'm going to get the same down on both sides. So I divided by -1, I have to flip it. Thank you. Now I'm just left with x minus 2 is less than 3. I add 2 to both sides, I get x is less than 5. And this question asks for the radius of convergence. So if you got all the way to this point and you said, boom, I got this, I don't have to test the endpoints because my professor told me I didn't. Right there's my interval of convergence, -1 to 5, done. You would probably lose a point, or you would lose a point, because that is the interval of convergence. If you're, that's your interval of convergence. It's asking for the radius of convergence, which is the distance from the center to the outside. So basically, find the average of these two. So find the midpoint between -1 and 5, and just take the average. So I add these together, get -4, divide by 2. I get +4, divide by 2, get 2. And then I know the midpoint on the number line. I have -1, I have 5, the midpoint is 2. I want the distance from 2 to 5. So the radius of convergence is 3. And that would be your answer in this question. And just a quick 2 seconds, who knows what interval of convergence actually means?
When x is equal to anywhere in between those numbers, then the series will converge.
Yes. So you guys don't care about convergence tests anymore because those are all on the first test, and you never have to care about them again in your life. But when you take this series, if you plugged in a value for x that was between -1 and 5, and you did tests of convergence, this would converge. If you plugged in 6, which is outside of the interval of convergence, this would not converge. That's what the whole idea for the ratio test, interval of convergence, radius of convergence is.
What are the 3 cases of convergence? So if it's 0, then it converges at all numbers, right? If it's not 0, then we do this, and then or if it's greater than 0, it only converges at the sense
Say that again?
I don't know, Lyra's at the sense center. It's like the way our professor did it, we compared like a -2/3, and you call this L, and L is like 1 over basically. And then it's not over L to greater,
It would be like
like you get 0.
-1 times 2.
Okay,
So it should work that
that makes sense. That's interesting, a way to find the radius of convergence. So I guess that does work.
You just have to remember that's the center.
Yeah, and the center you can find, if you go all the way to the edge, you can find it that way. You can do that too. Yeah.
It's always set at 0. No, it's not. So how does? Can you just add like 1 and divide the other and divide it by 2? Like can you
Yeah.
always add the endpoints?
Yep.
So how do you get to 3 and the 5?
Well, these were the endpoints that I got, the -1 and the 5. And I found 2 because 5 plus -1, 4 divided by 2 is 2.
Okay.
What was it? Did I answer the question? Maybe.
Never mind. So you can just add the endpoints together, like the absolute values of each endpoint, and then.
Not the absolute values. Because the idea is, like on a number line, we have -1 here, we have 5 here.
Okay.
We want to find what is the midpoint between these endpoints. Where's the center of this set of numbers?
Oh, so you found the middle and then you did 2 to 5? Okay.
Yeah, and the distance from 2 to 5 or from 2 to 1 is 3.
I think we can because it's all.
Like, does that make sense?
Yeah.
Because this is the center, radius is distance from the center to the outside, so it's 1, 2, 3.
And then you're saying
I don't
if
think
we make that equal 0, it's all real numbers. So what would the radius be?
I'm sorry, I'm not super familiar with that one. I can try.
So,
So like,
just because I didn't do this when I was in the class, you said if the limit goes to infinity,
Then it is only outside.
then it only converges at the center. So that would mean the radius would be 0.
0, and then if it goes to 0, it's all real numbers.
Then the radius would be all real numbers.
So the radius is all real numbers, and the radius is 0 is all real numbers.
So
Center, like
if the
center
limit
is,
is
you know, the
infinity,
center purchases 2.
that means interval and radius of convergence. So if the limit that you take becomes, so I guess when you get to like this point, when you take that limit, if it goes to infinity, the interval is 0, we said?
Yeah.
Which means the radius of convergence is all real numbers.
I think it's
No,
other way around.
other way around.
No.
If the interval is 0 and radius of convergence is the center, and that's only at the center.
Yeah.
Which you have.
So the interval is the center. So limit infinity, interval center, radius 0. Thank you. So again, we didn't do this when I was in the class. Which also makes me think that it might not be on your test, because like I said, they don't like to change the
It was
test.
only like a sample.
Yeah, it was just like an easy way to do it. It wasn't like something you could figure it out other ways. Our teacher just did like 1 over the limit of the radius.
Okay. No, that the interval would be, or like negative infinity to positive infinity.
Yeah, just the 2's just will cancel. Yeah, it's just Really is kind of convenient. Now that I see it.
Oh, and that makes a lot of sense. Because if the other way that you can think about that, and like this would be the last thing, because we spent a lot of time on what might be one question on your test. If the limit is infinity, that means that your a sub n plus 1 is much, much, much bigger than your a sub n. So it's going to converge down very quickly, which means there's only going to be one specific number that lets your sequence converge. If your limit is 0, as n goes to infinity, then that means it doesn't, your sequence doesn't dampen as quickly. I know that doesn't make a lot of sense, but it doesn't change as quickly, which means you can plug in a lot of different values for that x and you would still get the same result of it converging. Which is why you have that radius of convergence is infinity, because it goes on an infinite in both directions. Does that make sense? Okay. So with that, like I said, this might be one question on your test. So now we'll move on to some dot product and cross product, which is something that you'll be using in a lot of math classes, in a lot of science classes. So if you're not comfortable with dot product, cross product, get comfortable with it.
Not for real. I said that he was nice.
We do.
He's not.
The window.
Oh wow. Just speaking of that. No. You're not special. Oh, Lena, you guys probably were You were the first, okay. Does this make you feel better? You were the first.
You good?
I'm shook.
Shaking.
Why are you so
Alina's getting some shade.
Okay. Yeah, me too. Spread over.
It's not good for big guns. Yee. I'm gonna fall asleep. And like I have boy. What is that?
Okay, so we got dot product, we got cross product. These are the formulas that you really need to know for each one. So for dot product, A, some vector A dot vector B. The way that you calculate the value is the magnitude of A times the magnitude of B times cosine theta. You'll use this anytime a question asks you to find the angle between two vectors. If it asks you to find work, and then this gives out a magnitude. So the result that you get from this will be a value, it'll be a number, it'll be a magnitude of something. It won't have a direction to it. Whereas the cross product, when we do A cross B, which is very similar except A, B sine theta instead of cosine theta, the direction of this vector that you get as a result is going to be perpendicular to both vector A and vector B. So this is where your orthogonal comes into play, because orthogonal means perpendicular just in 3 dimensions. And since we have A going one way, we have B going another way, the only way you can have something perpendicular to both of those is if it's coming into and out of the board. So if I were to take the cross product of those two vectors, I'm going to get the vector coming straight out of the board. If the question asks you to find the area of a shape, you use cross product and then take the magnitude of the vector that you get, and again, this outputs a vector. So, example 3 on our test, on the test that I had, and this was fall 2015. Holy cow, that was a long time ago. Fall 2015. It was question 3. This one was, again, 8 points, relatively simple. I'm going to do it right here. And this one's a dot product question. It says a child pulls a little red wagon on a level sidewalk with a force of 50 newtons. So we got a little wagon. It's red. Fabulous artwork. At an angle of 45 degrees. Right here we have 45 degrees to the sidewalk. And this is 50 newtons. Find force vector F in terms of I and J. So A says find F in I and J. Part B said if the child pulls the wagon a distance of 10 meters, so we go 10 meters, what is the work? So the first thing, find force in I and J. So all that I means is find the X component, J just means find the Y component. So all of you, how many people are in mechanics right now? We got a couple. How many took mechanics of some sort in high school? Okay, so this should be relatively familiar to you, how we break down forces. We have 50 newtons going that way. We can represent this as two other forces, one going straight to the right, one going straight up. This is going to be our I term, this will be our J term. So the way that we find those is through some fun trigonometry, because we know we got a right angle right here. So I know that the X component of this, so F, which is that force that you're pulling with, is going to be equal to this line right here, which is going to be 50 cosine of 45. Because it's that horizontal line, and I know that that's in the X direction, so it's my I vector, because the I is the unit vector for the X direction. What that means is it has the direction, but it has a magnitude of 1. So multiplying this times I keeps the same magnitude and just gives it the direction that we want. Similarly, the Y direction is going to be 50 sine 45, and this one's in the J direction. So then you just multiply this out. If you don't have a calculator, if you leave it like this, you might even get full credit, but they'll probably want you to know that cosine of 45 and sine of 45 is just 1 over rad 2. So your F is equal to 50 over rad 2 I. Root 2 over 2 and 1 over rad, yeah. You don't rationalize, it doesn't mean shit. They just make you do it in high school because they don't want a radical in the denominator. There's nothing in math that says you can't have a radical in the denominator. They lied to you. I'm sorry. Go back to your math teacher and tell them that your life has changed because rationalizing means nothing.
Thanks.
So that's the answer to part 1. That's 4 points on the test. Find F in terms of I and J. Does that part make sense to everyone? Cool. Now, the next part says find the work if they move it 10 meters. So, work we know is over here on the dot product side. So, I want to find the dot product of, we need 2 vectors. So it's safe to say that one vector is going to be this F because that's what the question's talking about. What is my other vector going to be finding that magnitude, or finding the work done? 10 meters, right? Which way is that 10 meters pointing? In the X direction, because we're moving 10 meters this way. So I know that if I want to find A dot B, or in this case,